Hello guys, I wanted to make this video to talk about a topic that I consider is not that common in tutorials, at least the ones that I found, which is identifying responsibilities inside your code, that this can be extracted to very little classes or entities that handle that specific responsibility. So yes, that's what I wanted to show you. This is not mandatory or how you will find every single project in your experience. This is something that I wanted to see in my early stages as a software engineer. So we are going to see a very simple example with a timer that will increase a counter, but I think that will be enough to show you what I'm referring to. This is going to be in Swift, which is my area of expertise, but it's a very platform agnostic topic. So no matter what area do you prefer, I think this will be helpful for you in a way. So yeah, let's get into it. Okay, so here we have a very basic project as an app playground from Xcode. So let's try to identify the responsibilities of setting up a timer. We are going to start from a plain example of it, identify these little responsibilities, and see how we can remove it from the entity we are working on. So let's set a timer, which is going to be a timer, publish every, the time interval is in seconds. So if we set an integer of 1, it's going to be a second. We are going to set this one, and as we can see the time interval in the official documentation, this is a value specified in seconds, so it works for these requirements. We are going to execute it on the main thread, and let's keep this as common for now. So yeah, we have now a timer to make it this one auto connect. Okay, so let's attach this timer to this Swift UI view, and we are going to receive it in the actual view as on receive. The publisher is going to be the timer. We don't need to have a reference of the timer here, and we are going to increase a state variable of the count, which is going to be initialized as 0. We are going to present it in, we can get rid of this image, and we can update this with the string of the count. Okay, so right now it's not doing anything because we are not doing anything on the onReceive closure yet. So let's increase that one, count +1. Okay, so now this is working. This is being updated presumably by every second. This is working as expected. But what happens if we require any timer in other view or something like that? This can be seen as very trivial, but in a very big project, sometimes this is not the correct way or not the common way. Well, I don't like to say the correct way. Every team has its own way to do things. With the experience, you are going to see that every single decoupled dependency or entity will be very beneficial for future changes or even testability. Okay, so let's evaluate each of the responsibilities here. So this is the view, and this knows how to handle a timer with this line. This can be very simple, but this is actually knowing where is the timer coming from, when it's going to be triggered, and the execution thread, and many things can be seen as a responsibility that can be removed from the view. Okay, so for that one, let's remove it from the view and set it into a regular view model. So for that one, let's create a view model, which is going to be final class timer view model, and this is going to be an observable object that will have this state. This requires to be a published because this is okay now, but we require this one to be a published property. And I'm actually more experienced with UIKit, so I'm going to do it as it used to be. It doesn't matter for this concrete example. Okay, so we need to keep a reference to the timer just to keep it alive. So let's make it private. So private var timer timer, an optional one because we are not going to create it since the initialization of the view model. So let's add a method that will let the view model know when to start the timer. So func schedule timer, and let's make it as timer, schedule timer with time interval, repeats. Okay, our time interval is going to be 1, is going to be 10, yes. And we are going to execute this one. We don't need the reference of the timer inside the closure, but we need the count. We need to update the count. We need this to be a week reference, week self. It's going to be self count. Increase it by 1, and we need to fire the timer just to make it active. Okay, so this will start the timer when the schedule timer is being triggered. We are keeping a strong reference to the created timer just to keep it alive, and the compiler is complaining because we don't have any count property. Let's make a reference to the view model to be a state object, var view model and timer view model, and we are not receiving anything anymore. But on appear, let's make the view model schedule timer, and we are not going to display this one. We are going to display the count from the view model count. Great. Okay, so this is working as it used to be. Okay, and now the view doesn't know anything about any foundation timer like this one, doesn't know the time when it's going to be updated. This just knows when it should start to be scheduling this timer and what is going to be presented, which is the view model count. But we can still extract all this logic into another dependency, and the view model wouldn't know if it is a foundation timer or any third-party dependency timer. Okay, so the timer is a responsibility that can be removed from the view model too. So let's see how can we do it. As we can see here, we just need to pass what is going to be triggered and when to start. So let's create an interface for that one. It's going to be a protocol my timer. It's going to be a func schedule timer. Okay, we need a parameter which is going to be with a time interval as time interval to keep the same interface as this one, and the action which is going to be a callback with no arguments and return no arguments, and perfect. Okay, so I like to call this structural or tooling code as what is the source of it and what is the role in the project. So let's have it as a final class, foundation my timer. The protocol needs to be defined before the implementation. So okay, great. So now the compiler is complaining about not conforming this protocol. The protocol is just an interface in any other programming language. So let's have that one, schedule a timer with a time interval, and yeah, we can have all of this code here too. Okay, so now this class will be responsible for the life cycle of the timer, which is the actual timer and where is that from. This is from foundation, as we can see in the class definition. Yeah, as we can see, the timer is part of the foundation framework. So okay, great. This is asking for the actual action, and we are sending it as a parameter. So let's send it and trigger whatever we are passing to that one, and we don't need a self-reference here. Let's compile. Okay, good. And now we can pass this timer to the view model. So let's keep it private. Let my timer. I need to initialize it. The count is initialized with a default value, so we don't need it here. And when schedule timer is triggered, we are going to call this function from my timer, schedule timer with a time interval of 1 second, and the action will be, now we need the self-reference. So yeah, this can be a bit strange, but for now I'm going to still using the weak self, but we can have another video explaining about the weak reference and why this is required here and everything, but it's not the scope of this video. And let's see what happens with this one. Okay, now this is asking for a timer. So this is expecting a timer, so we are going to pass a foundation my timer to this one. Great, so this is working the same as we had it before, but now the difference is the build model doesn't know about any timer instance or where is the timer coming from, and doesn't need to handle the actual reference or the life cycle of the timer. This is a responsibility for this one, for the foundation timer. But this time interval type, what is this time interval type? As we can see, this is from the foundation framework. I really like to keep this kind of custom types out of my protocols, because I try to keep my protocols as independent as possible. So we can change this one, because imagine if the timer doesn't require it to have it as a time interval anymore, or we are using another timer that is not the foundation one, and the time interval is with another type. So we can use an enum for that, like a enum my timer interval in a way. So we can have a case that is going to represent seconds, and we will have an associated value of an integer. And let's use this my new time interval type instead of the foundation one, the time interval foundation one. And this will make my interface cleaner and my code more readable. Let's see how it gets. Seconds, I need every 1 second, so this is awesome. Okay, this is not considered in this one. So okay, so now we need something that changed this type into a valid one, because if we pass this one as it is, like the time interval, this will complain because this is not a foundation time interval as expected. Okay, so let's imagine this is the foundation my timer.swift file, for example. So if we have a mapper function that will convert this my interval enum into a type that is readable for the foundation timer, there's no issue. So we can have it as a function map interval to foundation time interval is going to return a foundation time interval, and this is going to receive a custom interval type, my interval. So let's see all the possibilities for the interval. 30 seconds, let seconds, and we need to have it as a time interval. Let's cast this one into a time interval type, and let's use this new mapper function, map interval. Okay, map interval foundation time interval, and this shouldn't complain anymore. Let's compile it. Let's see the preview, and yes, awesome, this is working as expected. We can increase it into 3 seconds, and yeah, this is now a very readable code. And now either the view model or the content view knows what is the source of the timer or how to handle it. But in general, having this abstracted into this protocol or interface has many benefits, like adding, I don't know, analytics into this specific timer. We can add any other component that requires this exact same timer, would be triggered by the same delay as this one, and no other entity knew about it, like the view or the view model, and we can be triggering 5 other view models if we want to. And reviewing this one, having the expected delay in the view model is okay, because this is expected to be business rules related in a way. So this is okay. And we now have this foundation my timer, sorry for the naming, but this is a completely reusable component that can be shared between your projects, and this makes the view model testable too, and this makes the view model ready for unit testing too. So there are many benefits on start to identifying this kind of responsibilities on your code. So yeah, as we saw, there are many benefits of having these dependencies split into layers and layers of code, or smaller entities that has a specific responsibility. I know this is a solid practice, but honestly, at the moment, I didn't realize how important or how helpful it would be having the code like this. But again, this is not written in stone. This is just to show you how it can be done. And yeah, this is something like I would like to know, as mentioned in my early stages as a software engineer. Hopefully you got something from this one. Please share how you handle this. What do you think about it? If it is over engineering or not, it doesn't matter. This is just another way to achieve a feature. So yeah, I'm open to any suggestion or any repository that I can take a look into, that you want me to take a look and provide feedback or just chat about it. I'm happy to help. I've been doing this for the last 8 years. And yeah, I'm always happy to help. Hope you got something from this video. Suggest any topic that you want. By the way, I left this project into a GitHub page. If you want to, you can find it in the description of the video. So yeah, I'm Will, and see you in the next video.